Hello everyone, so this is the part 2 of the earlier video of the chapter vectors of class 12th subject maths. So I was teaching you the types of vectors. I taught you the 3 earlier. Now I was teaching the 4th one, which is the localized vectors. Let us start. So what is a localized vector? Now, if I give you a vector which is AB bar, vector AB bar, and if I tell you that it has a point X on it whose values are determined, suppose in all the axes 3 X, Y, Z, so it is 4, 2 and 3. So now this vector becomes localized. You cannot move it in any other position or place except these, right? So this becomes a localized vector. But if its position or its coordinates in all the axes are not determined, then you can move this vector anywhere in space. Just keep the same magnitude and same direction. You can place it here also. Just keep the same magnitude and same direction. You can place it anywhere. So now this becomes a free vector, which was your 5th type, which is the free vector. Okay, very simple. Now next co-initial and co-terminal. This is so very simple. Let me tell you. Co-initial. What does co-initial mean? Now I already told you that if I take this vector, this is the initial point and this is its terminal point. So co-initial vectors are two vectors having same initial point. So if I draw another vector from the same initial point A, and this is the AB bar vector, then both these vectors are co-initial vectors because their initial point is same. Now you can easily tell me what is co-terminal vector. Very simple, whose both terminal points are same. That means ending point is same. So if this is your first vector, its ending point is here. This is YZ, XY suppose. Okay, and if I from this terminal point, if I take another vector which has same terminal point, ठीक है, same terminal point, my, vector my bar, then these two xy bar and my bar are co-terminal vectors. Very simple. So now you understood all the types of vectors. ठीक है, brilliant. Now let me start with the actual part, which is algebra of vectors. What is it? Algebra of vectors. Now algebra means everything: addition, subtraction, multiplication and division. But this will all become simple because in vectors I'm sorry, I had an accident right now. Not me, but my phone, my camera had an accident right now. Okay, so in vectors, if we take addition and subtraction, it has only two methods and which are very similar to each other. How do we add two vectors? There are two things we can do for adding vectors. First one is we can apply the triangle law, and the second one is we can apply the parallelogram law. Now what does both are very easy and you have studied these in your earlier standard. Triangle law means if I connect a vector A, its terminal point is B and initial point is A, and with its terminal point, if I join another vector B, then both their addition will be this resultant vector AC. Let me name it as C. So this is nothing but your triangle law. So you can write C is equal to A plus B. Now let me teach you the parallelogram law. It is also very simple. Here, this is your A bar, and here, this is your B bar. Let me draw a vector parallel to it in its opposite direction. So this is your B bar again. And let me do the same for A bar. Now here, the diagonal of this parallelogram is your resultant vector for A bar plus B bar. This is your parallelogram law. Now this was for addition. If you are asked for subtraction, you will do the same, just put minus here, because as you know, A plus B, and if the value of A is negative, so you can write it as this. Now plus minus becomes minus, so A minus B bar. Okay, now let us start with scalar multiplication. Now, how do we multiply two vectors? Now, in scalar multiplication, you just remember two things. This is not visible, right? Just a second. So, in scalar multiplication, you remember two things. First is, if you're given a vector A bar, and if another vector is given which is parallel to this A bar. Now as you can see, it is parallel, but is it equal? No, these are not equal. It's the magnitude of B bar is greater than A bar, but these are parallel, so the direction has to be same. Okay, so you can write this thing as A is equal to K times AB, isn't it? So K is nothing but the constant of proportionality, you can say, because this is I've written it in the exact opposite. I'm sorry. B is equal to, because B is greater, right? So B is equal to K times A bar, isn't it? Because as you can see, B is greater, so B will be approximately 2 times of A. So that is what I have written here, K. So that is how you represent two parallel vectors. Now here are 3 things to remember. When this K is greater than, is less than 0, which is negative. When this K is negative, then A and B are not in same direction. Their direction is opposite to each other. So when K is negative, then you can say A, if A is in this direction, then B will be in this direction. Okay. Now when K is positive, then both are in same direction. Okay. Now when K is 0, what will happen? Guess. When K is 0, then B will be is equal to A. Oh, I'm sorry. I'm so sorry. When K is 0, then what will happen? As we know that B bar is equal to KA bar. Now here if you substitute 0 into anything is 0. So B bar will become a 0 vector. Okay. Now what is K? K is nothing but किती टाइम्स जास्त आहे ना, एचा बीचा मॅग्निट्यूड एच्या मॅग्निट्यूडपेक्षा किती टाइम्स जास्त होईल. तर मग के रिप्रेझेंट्स नथिंग बट द मॅग्निट्यूड ऑफ दिस बी. So as I told you in the first part that a vector whose magnitude is 0 is called as zero vector. Is called as a zero vector. So here the magnitude of B bar is 0. So B bar becomes a zero vector. B bar becomes a zero vector. Great. Now there are also few things to remember. I told you earlier that any magnitude is nothing but its any vector is nothing but its magnitude into its direction, right? So if I ask you about direction, what will you do? You will take this in this side and it will become a negative. So this is how you describe a unit vector. तुम्हाला जर युनिट वेक्टर काढायचं असेल कशाचा, तर सिम्पली त्याचा त्या वेक्टरला त्याचा मॅग्निट्यूडशी डिवाइड करायचं, तुम्हाला त्याचा युनिट वेक्टर मिळेल. व्हेरी सिम्पल. नाव अगेन इफ आय टेक दिस फॉर्म्युला, let me rub it only. Now again if you know that is equal to A, what I have written, आत्ताच मी सांगितलं ना की any vector is nothing but its magnitude and its direction. So K is nothing but magnitude na. So and A cap आत्ताच काढला आपण. A cap was nothing but त्याचा मॅग्निट्यूड अपॉन त्याची डायरेक्शन. सो हा एक नवीन फॉर्म्युला बनला. ढॅन दॅट ए बार इज इक्वल टू के ए बार अपॉन मॅग्निट्यूड ऑफ ए. हा मॅग्निट्यूड कॅन बी रिप्रेझेंटेड लाईक दिस और जस्ट बाय रायटिंग ए अँड गिविंग नो सिम्बॉल टू इट. नुसता ए म्हणजे सुद्धा त्याचा मॅग्निट्यूडच असतो. ह्या दोन गोष्टी तुम्हाला समजल्या. आता काय समजायचंय तुम्हाला? झालं, हे सगळं सोपं होतं. आता सबट्रॅक्शन ऑफ वेक्टर्स पण झालं, ॲडिशन सारखंच असतं ते. आता ते जे लॉज आहे ना ते आपण बघूया. आता लॉज सगळ्यांना माहिती आहे. कम्युटेटिव्ह लॉ आणि असोसिएटिव्ह लॉ अँड कम्युटेटिव्ह लॉ, associative law, identity law. Here identity law also has two parts. One is additive identity and the second is identity inverse law. The fourth one is distributive law. And anything else? बस झाले ना? झाले. So what is commutative law? Commutative law is very simple. It is nothing but if we add a bar plus b bar, it is equal to b bar plus a bar. Sorry for the disturbance. Now associative law. What is associative law? Nothing. How I remember associative law is write a bar plus b bar plus c bar, write equal to, again write the same, and give brackets to any of the three. So if I give the bracket here in this side, I'll give the bracket here in this side. Both answers will give us the same result. Okay? Now this was your associative law. Identity law is also very simple. Additive law is what? Let me tell you. Additive is nothing but if we add a zero vector in any vector, then it will give the answer as itself. We all know this. And inverse is if I add the inverse of this vector with it, it will give the answer 0. Now what is the inverse of a bar? Now if this is your a bar, its inverse will be nothing, just its direction is opposite. So if this is on this side, how will I write this? I'll write this as minus a bar. So inverse of a bar will be minus a bar. Ata we all know this. Plus minus will become minus. So a minus a will give us 0 only. So this was your identity law. Distributive law is very simple. If you multiply anything with anything, like anything with anything means, suppose I multiply plus n into multiply two scalars into a vector, then what will happen? You know this. MA plus NA. Okay, you know this. And if I multiply two vectors with a scalar, multiply m with this plus multiply m with this. Okay, so MA bar